So this paper is having questions which are related to metals. This question is about the metal and the metal oxide. You can annotate on the screen. You can use the chat as well to answer. So this question, most metals have high melting point. One other physical property, you can mention conduct electricity. You can mention high density. You can mention sonorous as well. Iron often rusts. Two observations, sorry, two substances other than iron that must. So what are the two substances? There must be oxygen. Oxygen must be there, and as well as water should be there. The next is iron can obtain by heating the iron 3 oxide and a zinc powder. What can we deduce about the reactivity of a zinc from this reaction? What you can say about zinc? Is it more reactive than iron or less reactive? So it is more reactive than iron because it has displaced the iron from its compound. So that's then ionic equation for the reaction is shown. Identify the oxidizing agent. Oxidizing agent itself, it is reduced. And the substance which is reduced, reduction is a gain of electron. And in terms of oxidation number, when you identify, but always the answer should be in terms, as I mentioned here, in terms of electron. So which substance is oxidizing agent? The substance oxidizing agent, which should gain electron. So when you check the oxidation number for iron, it is +3 here, and here is 0. So +3 becomes 0, so means that changes a reduction. In case of a zinc, it is 0 become +2. So 0 become +2, this is oxidation. So iron, and because it has gained electron. An explanation part is there. Zinc oxide is amphoteric. Amphoteric can react with both acid and alkali. Describe two simple experiments to show that the zinc oxide is amphoteric. Name the reagent that you would use. Adding hydrochloric acid, fizz, or you can also say solid dissolve. Adding sodium hydroxide, fizzing instead of the solid dissolve is a right term because it won't fizz with this. If you mention like first one, you mentioned sodium hydroxide because with alkali it does not fizz. With acid it's fine. You mentioned fizzing, but in both cases the simple answer you can mention the solid will disappear. Like in both observations you can write solid disappear even with acid or with alkali. But don't mention here, you can see add a named acid and disappear, dissolve in both. Why fizzing is not acceptable? Because fizzing can happen with acid, but it cannot happen with alkali. That's why. In this question, copper 2 nitrate decomposes when heated. So we have to first balance the equation. Complete the chemical equation. Nitrogen, this is 2 and this 2 is also multiplied. So mix 4 nitrogen. Because it is CuNO3 in a bracket 2 and then 2 molecules are there. So if the one molecule contains 2 nitrogen, 2 molecules will be 4. So we have to write 4 here. And it will give copper oxide. And then we have to balance that as well. 3 multiplied by 2, 6 multiplied by 2, 12. So 8, 10 and then 12. So it should be 2 here. So when we heat copper to nitrate, it gives what? It gives nitrogen dioxide, which is an acidic oxide, and it also gives oxygen. When it passes through sodium hydroxide, so nitrogen dioxide will dissolve. Because why it will dissolve? Because nitrogen dioxide is acidic. So you will mention the explain why only X is collected, because this part, the nitrogen dioxide is acidic oxide and it will react with sodium hydroxide. That's why we only collect oxygen there. So you have to refer that nitrogen dioxide is acidic oxide. Nitrogen dioxide and other oxides are formed in car engines. Explain how nitrogen dioxide form in car engine. How it is formed in the car engine. So nitrogen react with oxygen in the air at high temperature, or due to high temperature, or due to electric discharge, you can also mention. Yeah, that's right. The part C is related to the moles. A teacher heated 18.18 grams. You can annotate on the screen to answer this. Calculate the number of moles of copper nitrate, copper 2 nitrate. Copper 2 nitrate, we just work out the molar mass, if you remember. Like copper was 64, nitrogen is 14 multiplied by 2, and oxygen was 16 multiplied by 6. So it was, I guess, 188. Number of moles. How to get the number of moles? Moles equal mass in gram divided by molar mass. So 18.8 divided by 188. This will give us the moles. Then calculate the maximum number of moles of oxygen. How to work out the moles of oxygen? Because it's a continuation of the question, so we have to go back to the mole ratio. So the ratio between oxygen and copper nitrate is 2:1. So you have to use the ratio that 2:1 is there. So if we have 0.1, so this will be X. So 0.05. Then calculate the maximum volume of oxygen in centimeter cube. So if we need the volume, it's moles multiplied by 24, but that will be in dm cube. If you want in cm cube, multiply by 24,000. Directly you can do. So 0.05 multiplied by 24, that will be in dm cube, and dm cube to cm cube we multiply by 1000. So we get 1200 centimeter cube. In part D, a sample of a copper 2 nitrate was dissolved in water to form a solution. As I mentioned, for paper 4, you have to memorize these tests and observations. For paper 6, you will have the qualitative analysis table. You will use that table and just write the answer. But for paper 4 and 2, you have to learn this. The aqueous solution was split into three portions. First, we had a sodium hydroxide, a light blue PPT form. Why light blue PPT? Because these precipitates are due to hydroxide. The copper hydroxide is there. A zinc powder, the solution changes the color. Why the solution changes the color? Because like it's a, we will mention instead what, explain the change seen in test 2. Why these changes are seen? So you can mention like zinc is more reactive than copper. So zinc will displace copper from its compound, and there will be a change in, there will be a redox reaction. But you will mention zinc is more reactive, or zinc displaces copper from its compound. That's why there's a change. Identify two reagents that must be added to aqueous copper 2 nitrate in test 3. We want to test for ammonia. What is the test for ammonia? So we add sodium hydroxide and then aluminum foil. Because this is a test for nitrate ion. That's good. Sodium hydroxide and aluminum foil. If it was only test for ammonium ion, then we add sodium hydroxide and heat. But for nitrate ion, sodium hydroxide, adding aluminum foil and then heat. Copper 2 nitrate can be made by reacting copper 2 carbonate with nitric acid. Write a chemical equation. So copper 2 carbonate the important thing is writing a correct formula. So copper is +2 and carbonate is -2. So copper to carbonate will be CuCO3. React with nitric acid, HNO3. It will give copper nitrate, copper to nitrate. So copper is +2 and nitrate is -1. So copper to nitrate will be CuNO3 in a bracket 2. Plus water will be there, H2O plus carbon dioxide, CO2. This is the equation that balance. Whenever you balance, start with oxygen, followed by hydrogen and then other element. So oxygen 3 plus 3, 6. 3 multiplied by 2, 6, 7, 8, 9 are there. So we need 9. So if we put 2 here, this will make 9 oxygen. And hydrogen 2 is balanced. Copper 1, so rest all of them are balanced. The carbon dioxide is added to air by living things. Name the process, that is respiration. And how it is removed by the plants, that is by the process of photosynthesis.